I sent you a picture.
Okay. Let me open my email. Haven't received it yet.
Okay.
Send it to David Cowan 1949 at Gmail.
Yep.
Well, is there anything on that that you can verbalize while we wait for the picture?
Not really, because it's like hypotenuse and like
Okay,
special
you're
rectangles.
saying right triangles?
Yeah.
Well, right triangles are governed by the Pythagorean Theorem. What's the equation that governs this right triangle?
What?
A squared plus B squared equals C squared. One of the most important theorems in all of math, that when you have a right triangle, the sum of the squares of the smaller sides equals the square of the hypotenuse. Okay? So that's huge. In other words, if I tell you that I have a triangle that's 3 there and 4 there, what's x?
What? Well, x is the hypotenuse, so it'd be 9 plus 16 equals 25. So c would equal 5. Or x would equal 5.
X equals 5, exactly. And that was no accident that I gave you this triangle. This is the smallest perfect Pythagorean triangle. And by that I mean the smallest triangle that has all integers. This is a huge triangle to remember. You're going to run into it for the next 3 years. Okay? But even if it's not a perfect triangle, what if I made that 2 and 7? What is x?
It would be 53.
The square root of 50.
Square root of 53.
The hypotenuse is always the square root of the sum of the sides. So in this case, that's the square root of 4 plus 49. So that's where you get square root of 53. And that's what that is square root of 53. Now, there are few skills in mathematics that are going to benefit you more than being able to solve right triangles. So let's solve some right triangles. This time, I'm going to give you the hypotenuse and one side. Now tell me what x is now. First of all, the first words out of your mouth should always be square root of. And in this case, it's going to be 8 squared minus 3 squared.
Mm-hmm.
which is the square root of 74. Excuse me, not 74. What am I thinking? 8 squared is 64 minus 9. It's 55. And that can't really be simplified. Okay? So let's talk about this. This is huge. Regardless of what you sent me, I want you to be able to solve right triangles. Okay?
Mm-hmm.
Now, the thing about right triangles is you can always go back to this to figure out how to solve them. But, and this is one of the few cases where I really don't advise my students to remember the basic equation, but because you have to solve so many right triangles over the next 3 years, it's really worth solving it when there's one of two situations. Either you have both sides and missing a hypotenuse, or you have a hypotenuse and one side missing the other short side. Okay? Well, the other short side, A, is always equal to the square root of c squared minus the other short side squared. And the hypotenuse, C, is always equal to the square root of a squared plus b squared. So these two things you want to remember. And notice that that's all you have to remember. In other words, if you're solving for the other short side, then it's b equals the square root of c squared minus a squared. The hypotenuse is always equal to the square root of a squared plus b squared. But one of the short sides is always equal to the square root of the hypotenuse squared minus the other short side squared. In other words, b is equal to c squared minus a squared. With me?
Mm-hmm.
I'm going to give you some examples. I want you to solve them for me. Tell me what z is. And give it to me from the beginning. In other words, I don't need a final answer. I don't care what a final answer is. Tell me how you figure out z.
It would be square root of 4 squared plus 7 squared equals z.
That's all I want. Well, let's do a little bit more. So that's 16 plus 49 equals the square root of 65, and that is simplified. That cannot be simplified any further. Okay? Let me give you another one. In other words, that one was missing the hypotenuse. This is going to have the hypotenuse. So solve for x. What's x equal to?
The square root of 8 or 10 squared minus 8 squared.
Okay, you got it. That's the square root of 36, which is 6. Okay? And notice that that's 6. That's a 3, 4, 5 triangle. And 3, 4, 5 triangles or multiples of those, this is 2 times a 3, 4, 5 triangle, are just huge. When you take your SAT or ACT test, you'll have at least 6 problems on there that will have a 3, 4, 5 triangle in it, or a multiple of 3, 4, 5. And that multiple could be 6, 8, 10. It could be 30, 40, 50. They're all 3, 4, 5 triangles. Okay? So if you recognize that, and I were to say, well, what is X? You can see that that's a 3, 4, 5 triangle, which means that has to be 6. In other words, sometimes you can solve these without doing the math. If you just recognize that you're looking at a 3, 4, 5 triangle. Take a look at my email. I still didn't get that. Can you resend it?
Yeah.
And make sure you're sending it to the right place. Usually people misspell it or they leave off the 1949. Make sure you're sending it to this email address. So are you on chapter 9?
I'm not sure. We haven't done anything in the book, so I'm not sure what chapter we're on, but
That's what you're on, is right triangles and trigonometry. And the most important part of right triangles is the Pythagorean Theorem. In fact, like I said, the Pythagorean Theorem is probably the most important theorem in all of geometry.
okay.
Tell me when it's sent. And you know what? I'm just going to keep giving you some of these because there is nothing that's going to help you more than doing these. What's Z?
Square root of 5 squared plus 6 squared.
Okay. What's Z here?
Square root of 7 squared minus
Plus?
sorry, square root of 10 squared, which would just be 10.
Okay. So that's the square root of 59. Is X equal to?
Square root of 2 squared.
No, always start with the hypotenuse. When you're solving for a short side, and that's what we're solving for, is one of the short sides. Remember, the hypotenuse is always the longest side.
Mm-hmm.
So when you're solving for a short side of a right triangle, it's always c squared is what starts. So it's the square root of 7 squared minus what?
So 7. Minus 2 squared.
Which all of that's equal to what?
The square root of 3.
Okay. Another one.
X equals the square root of 17 minus 5 squared.
Well, it's the square root of 17 squared minus 5 squared. What's that give us?
It gives us a negative number.
Ah, that tells us something. What does it tell us?
That it's unsolvable.
It's an impossible triangle. In other words, I have drawn this triangle with the hypotenuse being not as big as this short side. In other words, the hypotenuse is 4 and change, and this side's 5. Well, you cannot have a right triangle if the hypotenuse is not the biggest side. And so you find that out when you go to solve it and you get the square root of a negative number. It tells you that's an impossible triangle. If I make this 26, now it works, because now x is the square root of the square root of 26 squared minus 5 squared, which is the square root of 1, which is 1. So x would actually be 1 there. So always remember, the hypotenuse has to be the largest side of the three sides. And if it isn't, you'll end up trying to take the square root of a negative number. Have a look. There it is. You do anything different the second time you sent it?
I don't know. I was just having trouble sending.
Okay. Just curious whether it's... All right. It looks like all of these are pretty much what we've been doing. Now, there are two very special right triangles. And these are the two that are at the top here. One is a 45-45-90, and the other is a 30-60-90. And by special, I mean you're going to be dealing with these two triangles for the next 3 years also, right up through Calc C. Okay? So the thing you want to remember on these two triangles, and I cannot emphasize this enough, is what the relationships between the sides are. Well, let me draw it a little different than the way they do. And I'm going to call these my unit. Well, the 30-60, the side opposite the 30 is 1. Side opposite the 60 is square root of 3, and the hypotenuse is 2. Notice that that's pretty much what they've written here without the x. In other words, this is the same, it's a similar triangle if I said 10 root 3, 20. Those triangles are similar. Okay? Similar triangles are triangles that have the same three angles. You don't really care whether one is bigger than the other. I mean, this has a similarity ratio, a linear ratio of 10 to 1. But this is what you want to remember right there. What is it if the side opposite the smallest angle is 1? And likewise, the other triangle that's super important is the 45-45-90. And in my unit triangle, those are the dimensions. So what you want to memorize, and again, I cannot stress this highly enough, are these two triangles. Because you're rapidly coming up on trig. You're going to get a little bit of trig in geometry this year, and you're going to get a lot of trig next year. And trig kind of begins with these two triangles and what their dimensions. Trig is all about relative dimensions. In other words, the sine of 30 degrees is 1 over 2. Well, it wouldn't matter if this was 10 and 20. It would still end up being 1 over 2. So trig is all about ratios. So it doesn't really matter whether I use what I call a unit triangle here and here, or I express it the way they do in these pictures. To me, it's a little more confusing when you add the x. Notice that without the x, that's what I've drawn. 1 is opposite the 30, root 3 is opposite the 60, and 2 is the hypotenuse. And same with the 45, 45. We have 1, 1, root 2. If you're going to memorize anything, memorize this. And if you don't memorize it now, I'm going to be telling you or asking you to memorize it next year when you get the trig. There's just almost nothing more important than being able to draw from scratch what you see in that rectangle. All right, let's look at number 1. What's B?
35.
Okay, so now what we have is a 35, 35. What's that?
35 times the square root of 2.
Good. Yeah. In other words, you didn't have to use the Pythagorean theorem to come up with that, right?
Mm-hmm.
You didn't use it, in fact, I'm guessing. Because all you did was understand that that's a 1, 1 square root of 2 triangle. And it can be any multiple of 1, 1 square root of 2. And this happened to be a multiple of 35. Number 2. Also a right triangle. That side's equal to that side. What kind of right triangle is that? Is it a 30-60 or a 45-45?
45, 45.
Yeah, because it's an isosceles right triangle. In other words, because that side's equal to that side, that angle has to be equal to that angle, and the only way that works is if they're both 45. So, that being the case, what is x and what is y?
X would be 27 and y would be 27.
Good. Let's look at 3. Again, notice the first 3 problems they gave us were all 60, 30, or 45 triangles. So the way you're going to solve these aren't so much by using the Pythagorean theorem as much as knowing what this triangle looks like. So what multiple of this triangle is the one that I've drawn?
What?
What is it? How much bigger is it than my unit one? In other words, here's my unit one, which is 1 square root of 3, 2. What's the similarity ratio?
1 to 18.
What is it?
1 to 18.
I'm not understanding you, Allie. Can you say it one more time?
1 to 18.
Okay. Correct. or 18 to 1. I forgot for a moment that you have Yancek. You still have Yancek?
No, I have Miss Moore.
Ah, I have met Miss Moore also. She's only slightly less irritating than Yancek. Okay. So the similarity ratio is 18 to 1, which means this side has to be what?
18 to the square root of 3 to
Okay,
square root of 3.
that's the answer. 18 root 3. What's this side?
36.
Yeah. And again, you did not have to use the Pythagorean theorem, as all you had to use was your knowledge of a 30-60 triangle. All 30-60 triangles have these ratios, these exact ratios. Number 4. And that's 30. And that's 34. What's G going to be?
Dream will be 17.
Good. What's H going to be?
It will be 17 times square root of 3.
Good. All right, number 5. It looks like every single one of these problems is either a 30-60 right triangle or a 45-45 right triangle. So right there kind of tells you how important these are. Okay. And they want you to solve them using those unit right triangles. What's true about I and J?
They're equal.
Okay. Which makes this what kind of triangle?
An isosceles triangle.
Well, makes it a 45-45-90. In other words, it's one of those two triangles. Okay? And remember what the dimensions of a 45-45 right triangle are. So what is the similarity ratio here?
Uh, 26 is to square root of 2.
You see why I like going big to little as opposed to little to big? Big to little always leaves your ratio as a number greater than 1, whereas little to big always leaves it as a ratio less than 1. And it's much easier dealing with numbers bigger than 1 than it is fractions, especially if you're figuring out linear ratio, area ratio, and volume ratio. It's a lot different. So what is this side and this side equal to?
13 times the square root of 2.
All right, so you rationalize that. You got 26 root 2 over 2, which is 13 root 2. All right, good. I think you understand these pretty good. And you also seem to have a pretty good grasp on how to solve any right triangle, whether it's a 30-60-90 or a 45-45-90 or a 29-61-90. In other words, it is worth noting that on this page of problems, you do not use the Pythagorean theorem on any of them. you use the similarity ratio, right?
Mm-hmm.
Well, as soon as it's not one of these two special triangles, you're going to be using the Pythagorean theorem. So it's good to know how to do both. All right, Allie, I'm going to let you go. I have a 4 o'clock I got to get to. So
Okay.
I'm sure you can finish up these ones that we didn't do.
Mm-hmm.
I'll talk to you next Tuesday.
Okay. Thank you.
Bye-bye.